Alright, so today I'm going to be proving proof 21.1, which essentially states that A, d of f is the work form of grad f. Let's just do that. And then B, d of the work form of some vector field f equals, let's just do this, flex form of the curl of f, and then C, d of the flux form of f equals the mass form. I don't really know the symbol for mass form, but we're going to put mass form of the div of f. Alright, so to do this, we're going to draw a little diagram. We start with a function, and if you take the grad of a function, you get a vector field. And then if you start with a vector field and you take another, you take the curl of that, you get another vector field. Note that you can't take the grad and then the curl of the same function, because then you get 0, as proved in another proof. And then here, if you take the div of the vector field of a vector field, you get a function. Alternatively, a function corresponds to a 0 form, which if you take the d of that, you get a 1 form. If you take a d of that, you get a 2 form. And so the vector field, coincidentally, can't draw lines. The vector field, this vector field is actually the work form. Is actually a work form W, while this one's, is a flux form, and this corresponds with a mass form. So that's sort of a gist of what's going on here. So then, if using this diagram, if the grad of f equals dxf, dyf, dzf, then the work form of the grad of f equals dxf dx plus dyf dy, that's a d plus dz f dz, where also if you take the d of a work form, so the exterior derivative of the work form, you get d of the work form is fx dx plus fy dy plus fz dz. Oh no, it's gonna run into that. Which equals, if you do out all the expansion, you get dy f of z minus dz f of y. Dy wedge dz plus 2 other terms. Where this is the x component of the curl. And then the last thing that we need to prove is that, oh no, the light's adjusting, there we go, is that if you take d of the flux, you get d, so the flux is f of x dy wedge dz plus 2 more terms, which equals dx fx plus dy fy plus dz fz of dx wedge dy, oh no, dy wedge dz, oh, can't really read that, but that's okay. And this right here is the div. So then this is essentially the mass form, and then if you go to mass form of the div equals this form right here. And that is proof 21.2. Sorry about the lighting, the camera's adjusting, so I'm just going to pan down one more time. Alright.